Hey guys, Miss Kanata here. I'm just making this video as a review and preview of proportional versus non-proportional relationships. So the review part is we have looked at proportional and non-proportional relationships in tables and equations. And the preview part is that we are now going to look at proportional and non-proportional relationships in graphs. Now graphs are nothing new to us because we did learn about them last year. But looking at whether or not a relationship is proportional in graphs is going to be new to us. So I'm going to go through that today, and then that will help you with your assignment. As we know, a proportional relationship has a COP and has all unit rates the same. So we are going to look at proportional and non-proportional relationships in a table. So if we look at the first table, we have the number of mules and the bales of hay. I know that to get from 2 to 1, I can multiply by 1/2. And now I just want to make sure that that is the same for everything else here. So 4 times 1/2 is 2, 6 times 1/2 is 3, 8 times 1/2 is 4, and 10 times 1/2 is 5. So this is proportional. And the COP is 1/2. The second table, I can see that 4 times 4 is 16, 8 times 4 is 32, 10 times 4 is 40, and 1 times 4 is 4. So this is also proportional, and the COP is 4. Now we get to the last table where they find the unit rate for us, the price per pound, so 3 divided by 1/2, and that is $6 per pound. The second one is also $6 per pound. The third one is $6 per pound. But the fourth one, the last part of the table, says $5.50 per pound, and that is not the same as the other, so this is not proportional because there is no COP here. Now we're going to go look at equations. We know that proportional equations are in the form y equals kx, which is y equals k times x, where k is my COP. So I can see here 2 of these equations don't have multiplication, y equals 2 plus x and x equals 3 minus y. So these already are not proportional. And if I look at my other 2 equations, y equals 2x, this looks exactly like the format, and then y equals 1/4 x. Looks just like my format, so these 2 equations are proportional. Now, looking at graphs is where it gets a little tricky, but I want to show you that we can simply just turn all the graphs into a table because we do know that it is easy to find the COP in a table. Now, if you remember, this is my x, this is my y, so in my table I have x and y, x and y. This first graph already gives us the points, so I know I have 2 and 1, 4 and 2, 6 and 3, 8 and 4, and 10 and 5. Now this looks like the table we looked at above. 2 times 1/2, 4 times 1/2. So this one is proportional. The COP is 1/2. And another thing to look at is we do have a nice diagonal line here, so most proportional relationships will look similar to this, and it will be a diagonal line going up or down. We look at the second table, and if you look here, for all of my x's, 1, 2, 3, 4, 5, and 6, it has the same, they have the same y. So I know 1 times 2 is 2, but none of these are going to be multiplied by 2, so this is not proportional. And any time you see a graph where 2 x values have the same y value, it's not going to be proportional. Then we look at the third one. We have the x and y. I can see this is a diagonal line. Like the first one, it's just a little steeper. So let's look. I have when my x is 1, my y is 2, Then I have 2 and 4, 3 and 6, 4 and 8, 5 and 10, and then 6 and 12. Now I can see here that all of these are times 2. So this is proportional, with the COP being 2. And then we get to the last one. Now, as you can see, I said before, if two x values are going to have the same y value, it's not proportional. I can see that in the graph, but I do want to make a table just to show you guys that as well. So we have 1 and 2, and then 2 and 2, 3 and 4, 4 and 4, 5 and 8, and then 6 and 8. So already I know 1 times 2 is 2, but 2 times 2 is not 2. So this is not proportional. All right, I hope this helps.